welcome again to today's math class. We have a question on our board. We have that 3 raised to the power x plus 5 plus 7x is equal to 13. And we're asked to find the value of x. Now we're going to employ the Lambert W's function in solving this question. So let's get right into it together. All right, so from our question, we're going to move plus 7x to the right-hand side. So we have 3 raised to the power x plus 5 equals 13 minus 7x. Okay, so let's break up this because we know that a raised to the power m, a raised to the power n is equal to a raised to the power m plus n. So let's rewrite the left-hand side in the format of this formula. So this becomes 3 raised to the power x times 3 raised to the power 5 equals 13 minus 7x. Now, let's try to get rid of the 3 raised to the power 5. Well, we know that 3 raised to the power 5 is equal to 3 times 3 is 9. 9 times 3 is 27. Times 3 is 81. Times 3 would be 243. Okay? Right, so we have 3x 243 equals 13 minus 17x. So if we divide through by 243, through by 243, we have that 3x is equal to 13 minus 17x divided by 243. Now, let's divide through by 3 raised to the power x as well, so that we have just 1 on the left-hand side. And this is what we have. We have that 1 is equal to 13 minus 17x, 243. We can rewrite 3x, take it to the top, becomes 3 raised to the power minus x. Okay, so we want x to stand on its own. And at the moment, we even have a denominator on the right-hand side. So let's get rid of that denominator. So what do? We multiply both sides by, we cross multiply, and then we have 243 times 1 equals 1 times 13 minus 17x, 3 raised to the power minus x. So let's get the 17 minus 17 away from that x, or 17. Let's get 17 away from the x so that we have minus x at the base and also minus x at the power, because according to Lambert's W function, a e raised to the power a is equal to a. This a at the base needs to be equal to the a at the power, and then we have this e function that we're going to introduce later, and all these satisfy the Lambert W function. So we're going to employ this formula in solving this question. So let's rewrite what we have on the right-hand side. So if we take out 17, so we have just minus x there, it becomes 17. Factoring out 17, this becomes 13. It's not 17, sorry. 7. So we just take out all the ones. So we factor out 7. So we have 13 over 7 minus x, 3 raised to the power minus x. Right, so we're going to divide through by 7 so that we get rid of that 7 on the right-hand side. And now what we have is 243 divided by 7 equals 13 over 7 minus x, 3 raised to the power minus x. So now we see that we have minus x at the base and also minus x at the power. But we have 13 over 7 attached to the minus x at the base. So let's do the same. Attach 13 over 7 to the power as well. So we have 13 minus 7 minus x, both at the base and also at the power on the right-hand side. So how do we do that? We do that by multiplying both sides, the left-hand side and the right-hand side, by 3 raised to the power 13 over 7. We're multiplying by 3 raised to the power 13 over 7 because that way we have the same base, all right? And then we can add the powers. And if we add the powers, the base becomes equal to the power. So what we have is 3 raised to the power 13 over 7 times 243 divided by 7 equals 13 over 7 minus x. 3 raised to the power minus x. 3 raised to the power 13 over 7. So we have 3 raised to the power 13 over 7, 243 over 7, 13 over 7 minus x, 3 raised to the power 13 over 7 minus x. Okay, so now we have same power, same base. Now we know what we have left now is the e. We need to introduce the e somehow into this right-hand side of this equation. And to do that, we know that e raised to the power ln of x is equal to x. Okay, so x can be any value. Now, in our own case, we have 3. So let's rewrite 3 in this e raised to the power ln of x format. So now we have 3 raised to the power 13 over 7, 243 divided by 7 equals 13 over 7 minus x, e raised to the power ln of 3. Let's get rid of this. 13 over 7 minus x. Right. So now let's we have ln 3 being introduced into this equation on the right hand side. So we can multiply both sides by ln 3 so that we have ln 3 at the base and also ln 3 at the power. So let's do the same thing, multiply by ln 3. And when we do, we have ln 3 times 3 raised to the power 13 over 7 times 243 divided by 7. That's equal to 13 over 7 minus x ln 3 e raised to the power 13 over 7 minus x at the top here comes to the bottom here. And we have 13 over 7 minus x ln of 3. So now we see that our power and our base are both the same. And then we have our e function there as well. So this satisfies the Lambert W function. So we just apply that function to both sides of the equation. So what we have now is ln 3, 3 raised to the power 13 over 7, 2, 4, 3 divided by 7. And this is equal to, according to the Lambert's W function, this becomes 13 over 7 minus x ln 3. Now, we're done with the right-hand side. Right-hand side is done. Let's go over to the left-hand side and try to rewrite the left-hand side in the Lambert W function as well. So, we have ln 3. We have 3 raised to the power 13 over 7. Let's rewrite 3 raised to the power 13 over 7 in such a way that when we add or when we subtract, we still get the same value, 3 raised to the power 13 over 7. So we know that 13 is the same thing as 27 minus 14. 27 minus 14. 7 minus 4 is 3. 2 minus 1 is 1. So that's 13. 13 over 7. So 24 minus 14. Same thing. Here we have 243 divided by 7. And that's equal to 13 over 7 minus x ln of 3. So this is 27 minus 14. Okay. Now, this becomes 3 raised to the power 27 over 7 dot 3 raised to the power minus 14 over 7. Same thing. Times 243 divided by 7. And we have that ln of 3. So for 3 raised to the power minus 14 over 7, that can cancel out. Something can cancel out there. So 7 here is 1. 7 and 14 is 2. So we have ln 3. 3 raised to the power 27 over 7. Dot 3 raised to the power minus 2. 13 over 7 minus x ln of 3. Now, this becomes ln 3. 3 raised to the power 27 over 7. 3 raised to the power minus 2 is the same thing as 1 divided by 3 squared. And we know that 3 squared is 9. So we have 1 over 9, 243 divided by 7. Okay. And this is equal to 13 over 7 minus x ln of 3. Right, so let's see if anything cancels out on the left-hand side. We have 243 is 3 raised to power, how many? 5. So 3 can actually go through. 9 can also go through. So 9 here is 1. 9 here says 9 is 3 squared. 243 is 3, 5. So 2 from 5 will have 3 raised to power 3 left. And 3 raised to power 3 is 27. Okay, that's just some mental math. So we have 27 left here. Okay, so now what we have is w ln 3. 3 raised to power 27 over 7. 27 divided by 7. And that's equal to 13 over 7 minus x ln of 3. Okay, so we'll put this 27 behind ln 3. 27 over 7 behind ln 3. So we have 27 over 7 ln 3. And then 3 raised to the power 27 over 7, we can rewrite that by introducing our e raised to the power ln of x, because we're trying to write this left-hand side in the Lambert format, okay? So we have e raised to the power ln of 3 raised to the power 27 over 7, right? And this is equal to 13 over 7 minus x ln of 3. And this becomes 27 over 7 ln 3. This can come to the back, and we have 27 over 7 ln of 3. So we see that our left-hand side, the base on the left-hand side and the power on the left-hand side now look the same. And also we have our e as well. So now this satisfies the Lambert W function. And from that function, we know that this becomes 27 over 7 ln 3. Now this becomes equal to 13/7 minus x ln of 3. So now we have ln 3 on both sides. We can cancel out the ln 3's and then work out the value of x from what we have left. So we have 27/7 equals 13/7 minus x. So our x on the right-hand side moves over to the left-hand side, becomes positive. 27/7 on the left-hand side moves over to the right-hand side to become negative. So we have x is equal to 13/7 minus 27/7. We take our LCM. We have 13 minus 27. That gives us 7 from 3 is 4. 2 from 1 is 1. So that's negative 14 divided by 7. X is equal to 7 here is 1. 7 here is 2. X is equal to minus 2. Okay, so what's our question? 3 raised to power x plus 5, 7x equals 13. Okay, now we need to verify this. 3 raised to power x plus 5 plus 7x equals 13. So now let's introduce our x value, which is minus 2. So we'll plug in minus 2 everywhere we see x. So we have 3 minus 2 plus 5 plus 7 minus 2 equals 13. Trying to find out if everything on the left-hand side is equal to 13. So minus 2 plus 5 will give us 3. Plus 7 times minus 2 will give us minus 14. And now is that equal to 13? 3 raised to power 3 is 27. Plus minus will give us minus 14. Is that equal to 13? 7 from 4 is 3. 2 from 1 is 1. And this we have as our answer. Our left-hand side is now equal to our right-hand side. Therefore, our value for x, which is minus 2, is correct. So, if you've learned something new today, make sure that you like this video. If you like what I'm doing, subscribe. Make sure to share this video so somebody else can learn something new as well. I'll see you on the next one. Bye-bye.